Okay, thank you, ladies and gentlemen. I hope you've had a nice coffee break, suitably refreshed, and ready to go again after the very interesting talks we've seen this morning. So we have one more talk now, which will lead us up to the discussion session. And this talk is entitled Developments in Remote Sensing Platforms, Data and Services. And this is from Andy Nelson from the University of Twente in the Netherlands.
Thank you. Good morning, everybody. Okay, brief introduction. I'm a geographer by trade, which is like having a license to study anything, anywhere. It's quite a privileged position to be in, I think. It's a topic today that relates a little bit to my background. My interest is mainly food security and the use of remote sensing and GIS to help us better understand the risks we face in food security. I normally deal with modeling of yield losses from pests and diseases. Today I'm going to talk more about remote sensing and how that may be of interest from satellite remote sensing platforms and some of the data and services that are now coming out, particularly from a Eurocentric point of view. While I'm still allowed to talk as a European, I'm going to do that. And I'm really going to focus on things like Copernicus as some of the free and open data sources that we have. Before I really go into the data and services and what I think is needed for sustainable use of satellite remote sensing for plant health, I'd like to talk about some of the general trends, and these have come up in some of the presentations this morning already. We are in an era where we're seeing an increase in free and open resources. Remote sensing data is just part of the big data movement. We're also seeing huge advances in open source software to help us deal with a lot of this new data. We're seeing companies and institutes that you would not normally associate with remote sensing becoming involved. Google Earth Engine, Earth on Amazon, Microsoft even are now getting into this arena. We're seeing a lot of government and foundation funding for remote sensing applications. The Gates Foundation is a very big investor, USAID and others. And all the improved technology that's allowing us to deal with this data, cloud storage, cloud computing, artificial intelligence, and sensor networks that go much beyond remote sensing. All part of a new digital economy driven by data. So this is just setting the scene of where a lot of these developments are happening. I'm going to talk about satellite remote sensing, particularly the Copernicus platforms, and how these may be of interest to the plant health community. These are satellite platforms, so the spatial resolution is of the order of 10 meters and larger. You don't see individual plants that's been pointed out in presentations this morning, but you do get other characteristics of the landscape, which, as part of a system, when we talk about plant health, it's important to also consider landscape scale processes and how they may influence plant health. In particular, the Copernicus program provides satellite imagery globally. It has a long-term financing program with the European Commission and the European Space Agency through to 2030, and the next generation is already being planned for 2030 onwards. It's an open data policy platform. All the imagery that comes out of it, the data, the raw data from the remote sensing platforms is free, and there's a lot of emphasis on developing the software to process this too. The coverage of Europe from Copernicus is impressive, purely because of our geography of being quite high in the northern hemisphere means we have a very good repeat coverage for many of these satellites, and the resolution is available on an almost daily basis. I'm not talking about the Meteosat data here, which is much more frequent, but here about the remote sensing in terms of multispectral and radar data. Here's a slide from the European Space Agency looking at where we are with the Sentinel program of satellites. So far, Sentinel 1, 2, and 3 are up. 1 and 2 are fully operational, 3 going through some calibration processes but becoming online, and Sentinel-5, which I won't talk about that much because it's not really that relevant for land and water surface monitoring. But this is where we are at the moment. We have everything in green in A is up and running. Briefly, Sentinel-1. I'm going to talk about the different platforms quickly here. Sentinel-1 is a radar satellite, synthetic aperture radar, which gives us the ability for all-weather, night and day observation. It's this kind of seeing through the clouds type of system, which has a lot of advantages in areas where cloud contamination is quite pervasive. And this can even happen in parts of Europe, where it can often be a challenge to get satellite-based optical data because of cloud contamination. The typical resolution you may use is about 20 meters, and the coverage of all Europe, again, it's impressive. Every couple of days, you can cover all of Europe with this information. It's really got applications in crop type mapping, land management, forestry. You can see soil moisture. You can do estimates of biomass, canopy structure, and it also has applications in natural disasters, looking at the impacts of an earthquake, for example. I suppose the question then was, what's the relation to plant health? Again, I go back to the multi-temporal aspect of these sensors. They're operating every 1 or 2 days, so you have this monitoring capability that may relate to canopy structure, changes in it, changes in biomass, and changes in moisture. There's no diagnostic component to this type of information, but it might help you to see, well, something has changed here. Why has it changed? Does this merit further investigation? One thing which is really interesting from an agricultural perspective is that you can detect management practices, tillage, duration of fallow period, cropping intensity, things that do have an impact on production situations, which do have an impact on the risk or likelihood of particular pests or diseases occurring or flourishing. So again, it's not observing plant health directly, it's characterizing the environment in which we have to consider plant health issues. Sentinel-2, and I think this same image has been used in a slide this morning, is an optical multispectral sensor. And again, it's providing continuity for existing missions from SPOT and Landsat, giving us an incredibly rich time series of data about the land surface in a multispectral view. Resolution from 10 to 60 meters, again covering Europe every few days, and really looking at land use and land cover. Very important for coastal zone monitoring, coastal pollution, lake pollution, and again, disaster relief. It's an optical sensor, so cloud cover is a problem, even in parts of Europe. Where I work, often in the Netherlands, and even some parts of Italy, it's been quite frustrating trying to get cloud-free observations during key parts of the season, particularly in the early growing season in spring. What kind of information do we have here that's important for plant health? Well, we've got the visible information, red edge, and near-infrared bands, and this is really important for agricultural and forestry practices. You can say something about leaf area, chlorophyll, and water content. And again, it's the time series component, the regular observation. Can we see when crop stress occurs? Can we use that as part of a monitoring system looking at crop health? And again, diagnostic information is extremely limited, even zero. But again, it's looking more at the landscape scale. What can we say with this type of information that would complement other more detailed sources of information? And the final Sentinel I want to talk about is looking at land and sea monitoring. Sentinel-3 has multiple sensors on board. The most relevant ones, I think, here look at land surface temperature. So this is giving us thermal information and what we call land color. It's a relatively coarse resolution, 300 meters. These are huge pixels covering multiple fields. And again, it's the regular observation, land use change, fire and forest cover monitoring, where this platform has a lot to offer. Vegetation condition is something that these type of platforms are used for regularly. What has changed in the last 10 days or the last 30 days? Does this look any different from a normal season? Are we seeing something that should trigger an alert? Is there an anomaly in the vegetation condition? And if so, what action would be needed to go and investigate it further? Because this is building on existing monitoring systems, we've got data long-term going back to 1998, where we can say something about the condition of vegetation. Sentinel is expanding. There's a Sentinel expansion plan, and there's also the Earth Explorer missions. And these are just some of the other missions that are forthcoming, which I think are going to be very interesting for plant health. FLEX, which looks at fluorescence. I think Peter had a great slide that looked at this, and the very small percentage of the sun's energy that is represented in fluorescence, like 2%. So if we can say something about that with satellite-based remote sensing, looking at vegetation and fluorescence, this will be a really useful addition to our sensing capability. There'll be another platform coming soon looking at thermal infrared. And again, what you can see sometimes in the thermal part of the spectrum can be an early indicator of crop stress that's not always visible. Another SAR satellite, which I think is going to be important for soil moisture. And eventually there will be, it's in planning still, a hyperspectral image mission to complement perhaps some of the hyperspectral sensing work we've seen today from UAVs, drones, and so on. I think I'm repeating a topic that came up this morning, but I'll briefly cover it here. No single sensor can provide the detailed and frequent observations across all the spectrum. So a multi-sensor approach, this kind of cooperative sensing, whether it's remote sensing, whether it's in situ sensing, whether it's wisdom of the crowd type crowdsourcing that Google and others are taking advantage of through the photos that we share through their systems. All of these information sources can be brought together to help us better understand condition and the physical and chemical properties of an object. And I'm talking here mainly about Copernicus, which is free and open source, funded with the European Commission, managed by the European Space Agency. But of course, there are always a lot of commercial providers in this arena too. And they can provide very high resolution, and you've seen some of those examples today. One of the biggest recent changes in remote sensing is the miniaturization of components. When I started remote sensing about 20 years ago, satellites were the size of a bus. And you'd take a very particular platform to get them up there. EnviSat, I mean, it would fill this room. Now, we can launch platforms like this, Doves, microsatellites, CubeSats, nanosats, whatever you like to call them. And you can send up dozens of them at a time, giving you a constellation for incredibly regular observation at high resolution. They may only provide RGB or very simple multispectral imagery that only covers a few bands, but still, it's an important part of a regular monitoring capability. Planet, the company here where this drone comes from, has the aim to image the entire Earth every day with resolutions of about 1 to 3 meters. We've seen a lot of applications this morning with drones, and this has been the second biggest change in recent years in remote sensing. And it's not just the drone technology, but it's also the compact sensors that you can put on them. It's the user-friendly software that you need to be able to plan and process the imagery. And they started with simple optical cameras, then multispectral imagery came, hyperspectral, and now there's some really exciting emerging technology with LiDAR and SAR. I never thought I would see the day where you could put a SAR sensor on a drone, but it's likely going to happen in the next few years. The reason being that SAR sensors are huge in general. They're very big. And it's the high resolution, it's their fly-on-demand nature, means that they have a wide range of applications for monitoring plant and crop health. You want to go out today, you can go and do it with a drone. Is there anyone here from the Netherlands? Right, I'm going to show you a slide of what can happen to drones in the Netherlands. Legislation. The Netherlands, to the best of my knowledge, having lived there for 3 years, has some very restrictive conditions when it comes to flying drones. If you don't have authorization, this is what can happen to you. There's a police-trained squadron of Eagles who've been specifically trained to take out drones if you're doing something you shouldn't. Be very careful if you have a drone and you go to the Netherlands. We, in Enschede, are very close to the German border. We do all of our drone work in Germany, just because we don't want to deal with the paperwork. Now that's the data side of things. And it's great having all this data available, from satellite remote sensing coming in every day, covering all of Europe at incredible resolution. How on earth are we going to process that? How do we deal with this? And platforms like Google Earth Engine have emerged to show how you can do this. It's this kind of bring your algorithm to the data approach. Whereas in the past we'd have been downloading imagery, now we don't. The imagery is stored somewhere else on a cloud platform. We can then access that vast amount of data, and we can run our algorithms on that data in the cloud. The first major application of, I think, Google Earth Engine was for global forest monitoring, which has been published quite widely in Science and other outlets. For any of you who've not seen the Google Earth Engine interface, it's a web-based interface like this, and what I like about it from an educational point of view is that you have everything in one place. You have all the scripts that are available for you to do different things, like landscape cleanup, reducing a region, writing your code, looking at the imagery, seeing the output. It's all there in one place. This makes it really easy for people to quickly prototype ideas. I can go to Google Earth Engine, write 2 lines of script, and get access to 30 years of remote sensing data for any location in the world. And that's something that I would never have been able to have done before Google Earth Engine came along. It's been used for crop yield estimation. It's been used for predicting malaria outbreaks. It's been used for mapping land use change, mapping deforestation, access to resources, and others. So it's something that's really becoming used not just in research, but it's becoming almost an operational tool in some applications. Google isn't the only one doing this. Amazon's joined the game on their web services platform. Digital Globe, which is a remote sensing imagery provider, is also in on the game. Microsoft has now started with a Microsoft for Earth initiative. And then we start thinking, well, there's no major European player here. How come this is all the big multinationals doing this kind of work? And there is a European player. It's called DIAS, which is the Data Information Access Service. And it's run again through the Copernicus program. The Sentinel missions are one part of Copernicus, and DIAS is another. So DIAS is going to sit on top of this data and allow people to use it and process it. As much as I like Google Earth Engine as a platform, as a researcher, I do sometimes question the motives of Google in this platform. Their business is in selling advertising to people. I don't see the business model behind Google Earth Engine, and that makes me wonder, are they going to maintain this? If there's no business model behind it, what are they doing it for? Now, maybe it's philanthropy. Maybe it's just out of the goodness of their heart, they think this is something that they can provide with their technology. But I wonder then, is that a platform where you could have an investment and have a stable operational system if you don't know what Google's plans are with Google Earth Engine in the long term? I don't have an answer to that. I really don't know. Whereas with DIAS, this is coming at it from another angle, built within the Copernicus system, something that would be sustainable, although it is going to have a cost associated with it. The business model here is that the data from Copernicus is free, but you pay for the services. A lot of text here. Why DIAS? Well, the Commission identified there's need to access all of this new Copernicus data. Provide the facilities to allow people to do it. Because when all of the Sentinel satellites are up and running, Copernicus will be the 3rd largest data provider in the world. It's an incredible amount of information that's going to come out of the Copernicus system. There isn't a current cloud processing service available, but DIAS will kickstart the development of that. And the idea is that you're already bringing in entrepreneurs and developers and businesses to say, what do you want from DIAS? How should it look? Who are the users? So they're already thinking from the very beginning of a business model that will make DIAS sustainable. I think the simplest diagram I've found about how DIAS works is that you have all of this wonderful remote sensing data here. We need some kind of interface between the data and companies and developers, and those who provide a front end or a nice interface, if you like, so that end users can more easily use the Copernicus data. It's expected that this will be something that's going to guarantee performance. It's something that should be really an operational system. Again, there's the emphasis on growing the European Earth observation industry, attracting businesses to this to say, look, this is a platform where you can deliver services to your clients and customers. And it's trying to stimulate growth in this area in Europe. And the idea being that each community can build their own environment on top of DIAS. Whereas Google Earth Engine is something for everyone, you have to build your own code. Through DIAS, the idea here is that you'll have people working as developers specifically to address the needs of the community and provide services that would meet those needs. So again, coming back to that, there's a built-in business model idea behind DS. I'm just going to finish with, I think, what are 7 interesting points that, from my background, are related to how remote sensing can be part of a sustainable global food system. But I think the points are generally relevant for plant health as well. And these are the 7 points I want to quickly go through. The level of readiness of technology, validation and calibration of what we do, complementary use of remote sensing alongside other sensor networks, the increased take-up of information technology within agriculture, the frameworks we need to make sure that we have fair and open access to remote sensing. I think the FAIR principles were mentioned in a previous presentation. Ethics and governance, talking about eagles taking out drones and things like that, and the capacity of practitioners to actually use this data. So I think these are things that all need attention for us to have remote sensing truly meet some of the promises that some people think we haven't actually met yet. I think we've met some of them, but maybe not all. There's a lot of text here, I'm sorry. If the slides are going to be made available after the talks, I'm not sure, but you're welcome to have these. I'm welcome to share them with you. Very quickly, readiness of technology. There's a lot of companies working in this area, and which means there are many more options for implementation, which should reduce the cost of acquiring information. And I think there are questions still about whether the technologies and these large constellations of drones can really meet expectations. The technology looks fascinating. Is it going to provide the information and the quality of information that we need? There is a big gap between the data that we collect from remote sensing and the ability to collect ground truth information to validate it. Whilst we can collect petabytes of information quite easily, how do you mobilize sensors and people on the ground to help us understand that what we see from above is really true? And I think this is an issue that we have to address really quickly. Is it citizen science? Is it ground-based sensor networks? What other information can we use to better calibrate and validate this information? Remote sensing doesn't stand alone. I don't think I need to say much about that. It's been mentioned several times. It's part of an observation system only. There are some things we can do with remote sensing and some things we can't. Developing formal links between different communities and scientists, the whole data science ecosystem, this is really essential. That has to happen. Agriculture, I think, has lagged behind many sectors when it comes to the use of technology. Energy, transport, and others are way ahead in the use of big data. Agriculture, I think, lags behind. We are now seeing a proliferation of low-cost mobile devices, apps, and information services, but it's catching up, but it's not there yet. Frameworks, again, fair and open access to remote sensing. One of the biggest concerns I have with my work is the digital divide between the countries who have fair and open access and the countries who do not. And I'd like to see us working much more closely so all stakeholders have equal access to data. Ethics and governance. Who owns the data? Privacy, security, responsibility, and liability. The more information we collect, the more that we act on this information. These are issues that are quite tricky to deal with, but we're going to have to address them. National policies on UAVs have already mentioned that. Arrangements about access to remote sensing data. This varies from country to country. Open data requires a lot of changes in cultures within many of these organizations. And developing the capacity of the practitioners. This is in government, development agencies, and the private sector. Making sure that we have people who can make the best use of this data. Understanding the physical processes that we're representing with remote sensing. And I think there's a bit of a gap here in some areas. My institute, ITC, has been training people in GIS and remote sensing for about 50 years. We offer a lot of courses in this area, but we're only one part of a system of training networks across the world. But I see an enormous growth in being able to engineer and manage all these systems in an integrated way. It's no longer just remote sensing. It's looking across the whole diversity of sensor networks. And this is something where I think it's going to be a very exciting time as people become adept at working across this range of information to make the best sense of it. And that's all. Thank you very much.
Good, thank you, Andy. In fact, I'm going to ask you to come back up to would all the speakers from this morning please come up and sit on the dais? I think it would be nice. It would be the opportunity for the audience to maybe ask specific questions and during the discussion. So if you could all, if you've spoken this morning, please come and take a seat up here. and then we will move into this discussion session. Before we start that, though, I would just like, mainly for my own benefit, just to get some idea of what the audience consists of. So I'm going to ask you to put up your hand if you are, if you think you're either a government agency or an academic researcher, or from an academic research institute, or from a service provider, or an end user. So I'll be asking 4 possibilities just to see what sort of cross-section we have in the audience. So if you're from a government office, a government agency, quite a few, probably about, I would say more than 50%, 60% there, okay. A scientific research institute, maybe both if you, yeah, okay, a few, yeah. What else is there? A service provider, one service provider, and an end user. We have a couple who think of themselves as end users. Okay, so very small. So it seems to me that in this forum we're very much coming at the issue from the side of government, of the public sector, policy, maybe research a little bit, but less so from the service provider end user. So I think it's important to bear that in mind. Now, I would again like to reiterate my thanks to all the speakers this morning for, I think, really excellent talks. And I do understand that the presentations will be made available in due course, and it will be published how to get hold of the presentations. I think excellent presentation material there. And I think I will certainly make an effort to dig it out and start referring to it in what we're doing in EUROSEE in the future. But as I have listened to these talks this morning, I think the 2 things that I would like to try and start to kick off a little bit of discussion about. Firstly, one is, for me, one of the most important things is research operations gap. And the second is the issue about, yes, it's a bit more difficult to put a title to it, but making data available and accessible. So first of all, I would like to maybe just ask and the panel perhaps can respond if they wish. I mean, some of you have already talked about it, but in our work in EUROSEE, we often see many very clever research projects being proposed, particularly for the European Commission, for Horizon 2020, lots of very clever things being done. But as soon as the project funding runs out, then the project dies. And this, I think, is due to a number of reasons, often largely because, I mean, it's a sort of technology push approach where you've got very clever scientists and engineers wanting to do clever and interesting things. But we're not always very good at understanding user needs and understanding how users might end up using a particular application in the future. So maybe I'd like to perhaps ask the members of the panel if they would reflect a little bit in their experience about if they have been part of research projects that have experienced that stop. You know, when the project funding runs out, why has it stopped? Is it due to lack of understanding of user needs? If it is, how do you really go out into user communities and assess the user needs? I think this is a particularly important issue, and especially as I just remarked, you know, seeing that most of this audience is really coming from the sort of top-end public sector. How do we understand what the users can really need? Do any of you have any thoughts or?
Okay. Now, yeah. Okay. Yeah, this is really a good point to transfer from scientist to practice, and it's not easy to to explain this or how we can manage this. I also teach remote sensing as a biologist at university, and often I try to give them students the feeling how how the complexity of this process is. And the process is started really not in analyze and remote sensing. It started really with the process of data science. The data science means that we have really to manage the scientific information, to get the information from the remote sensing sensor, and to transfer this to that we get these results. But important is that we start to teach people or students in data management and really that what I showed that we have in the end that we have it make easy for people who not really confirm or who not really able to work with remote sensing data and what on, but really this part that we get easy tools, that a better understanding of a pattern process and what is working, and this is really what I see what we have to do in the future.
Yeah, there's. I can give an example of where I think it's worked quite well to bridge this research gap. There's a funding mechanism in the Netherlands that was called G4AW, Geo for Agriculture and Water. And the idea of that was to use geoinformation very much as part of a business proposition. So from the very beginning, the project fund was treated almost like a loan. After 3 or 4 years, we expect you to have a working business model. We expect your consortium to be working from day one with end users who are going to be dependent on the workflow where the geoinformation is used to inform them for decision making. This was looking at crop insurance, for example, looking at a drought index. So how to use geoinformation to reduce the basis risk of the insurance company so that they could have a much more cost-effective product. And that type of interaction from day one, making sure that you saw how your research was going all the way through to a product and a business and something that could be sustainable, that it wasn't easy. It was really hard as a researcher to be in that environment and to be communicating and learning how to talk to these different people. But that was the way that we saw, if we can keep that type of model in other areas, we could actually find a way to better help people understand the process of research, because that doesn't happen overnight. Sometimes it can take 20 years until something goes from a lab into the field. But you can actually have people working with you to set the standards, to define the requirements, and then produce something that eventually will provide something that's going to be successful on its own right without project funding. I'm not saying that this is a panacea, but it's a model that I've seen work quite well.
Well, I'm a pathologist, and as I say, I'm also involved with the MPPOs, and the problem is that you have a lot of technology you can transfer, but someone has to use and know how to use. So what is needed is to have a team in the plant protection services, multidisciplinary, which can really at first understand the potential of all this technology and also optimize the cost. As I was showing today, hyperspectral images which are expensive may be shared as cost with other purposes of the same public service. So it cannot be only for plant health, it could be for many purposes. So some costs can be shared because they say, oh, it costs a lot, which is not true. And so is it just that you have to really train people to first understand the potential, and secondly, how to use these tools once the research is finished, once you are proving that it could be part of the operational program. But then someone has to handle these tools. And this is, I think, is one of the major gaps. So we have to also to focus on training programs dedicated.
Yes, I think that's very good answers, I think, to it. And I'm also reminded of the answer that Paul gave to my question this morning about, whether any of the examples that he showed were operationally used. And he said, well, you have to actually put it in the hands of the farmers. And I think, to me, that is important, that farmers are, I mean, I'm not a farmer, but I understand that farmers are generally pretty conservative people, that they don't necessarily embrace new technology unless you can show them that if by spending €1,000 they can save €1,500 and increase their profits accordingly. For farmers, the bottom line is not the use of the technology or using interesting techniques. The bottom line is the profit margin and whether they're earning money. So you would have to communicate to them that by adopting the new services, new applications, they're actually increasing their bottom line. And I don't know how much of that really delving into the business models of the end users is something that really happens. Maybe, Paul, you could expand on that.
I think you're right. It's key is to understand from a remote sensor point of view. We go out and ask the questions, what does the end user need? What is their requirement? What would they like to have in an ideal world? And then there's the academic research, which is focused very much on early stage research and development, and sometimes that ends up in a publication, but then it goes back to another research. It's translating that. It's looking at that research and then translating it to the end user's need. I think that's what we need to focus our skills on. I think as a community, that is what we are trying to do now. We recognise we're getting to grips with the user needs now, and we're recognising what research is relevant and then translating that through with the new technologies coming online.
Maybe I can open this up to the audience now, please. I mean, if any of you in your public sector roles have dealing with policy on how to actually implement these things, perhaps you could make some comment. If you could identify yourself, please, and your institution.
My name is Juan Suarez. I'm working for Forest Research, UK. I just wanted to complement the traditional view of how we can translate this technology to farmers. As you say, it's very traditional, farmers and foresters. They're very conservative in their approach. You have to show the economic advantages. But sometimes it's not only the economic advantages. I was talking to a company that was developing satellite-based applications for farmers in the southwest of Spain. They were showing them where plants needed more water inputs, or more nutrient inputs, and they were recognizing that the gains probably in terms of productivity will be between 5 to 10, 15%. But what is really making this application very attractive is the sense of control, because every now and again, every few days, they will have an image, showing them the properties and the current condition, and that is a feeling that the customers really like, because it's very difficult to get it otherwise unless they spend all their lives in the fields. Okay.
My name is Silvia Blumler, Austrian Agency for Health and Food Safety. Well, I think we should not try to find one single reason why farmers might be conservative or not. I do not see it this way. I think they apply new technologies. They're very interested, not only because out of money. There are different reasons for that. I think one example is the forecasting services, which they use for pests, or there are a lot of technologies for precision pesticide application and so on. And I think the end users related to the topic here are also the National Plant Protection Services, those who are doing actually the advisory service and the monitoring. And for them it's really interesting. And probably here we really have a big need to train those people that they get knowledge about what's applicable, what is already there, what can be used, but also to tell them about the limits. And I think the presentations, they were really, really very nice. I thank all of you. It was so impressive so far that you have shown the options for the future, but also the current limitations. And I think for our understanding, it's very important to see that it is an additional tool which can be used. So, and something very important I would like to ask Anna Maria. I have told you in the break already. You have said it's very important that those who make the decisions at that level also try to link different disciplines in the different organizations to make use of all these knowledge and technologies which related to remote sensing, what has been presented today. That it's too fragmented and people do not know about these technologies in the different disciplines. And I think this is a very important thing. So, but I cannot see that farmers as such are conservative not to use these new technologies. I think they do it. It depends on the size of the farm and what they are doing, which crop and so on. There are so many factors influencing this. So anyhow, thank you very much for your presentations.
Oops. What is important for plant protection services is to change strategy for surveillance, because so they have to change also competences. Add competences inside a team, and this really will save a lot of human resources, because usually these are the problem: human resources and funds. So once you have set up a strategy for one pest, you can do with all this type of data, ground, remotely. And so this is an approach that should change for plant protection services.
Okay, thank you. And then, in fact, yes, I take your point. I shouldn't make generalizations. Generalizations are generally not true. But no, I was being a little bit provocative. But no, I fully take your point. Yeah. I think we have two other questions. Would you have a...
Hello, I'm Nicola Spence. I'm head of the MPPO in the UK. So this technology is very, very important to us. We support some of the work at FERA. And I think particularly at the moment it helps us direct our efforts on the ground. And it was interesting, you know, Peter's comments about, you know, how the Holy Grail is to kind of replace that. But actually the critical thing is linking that data with what's going on the ground. But I wonder, where do we then include the end users and the public? Because increasingly, obviously, farmers are building GPS into their tractor cabs, or they're using kind of robots to do their farming, and citizen science is out there doing informal surveillance, gathering data points, you know, feeding them through an app or a reporting system. So I don't know if there are any thoughts about how we connect all that together in the future. Thank you.
Yeah, I think it hasn't received much attention, but and I think in part of the traditional remote sensing community, or maybe also the plant protection community, there might be a bit of resilience to the citizen science branch. And others, I'm certain there's not. But maybe one thing that didn't come forward quite so much is that a lot of those image analysis techniques that go after objects, rather than doing pixel-level analyses, can be applied to crowdsourced images. And I know in the realm of the new Common Agricultural Policy, there's research going in that direction. Farmers, not for pests, but for crop and practices, self-reporting through images what they're doing, that being automatically analyzed, compared, validated, corroborated with satellite data. So I think the spectrum is opening up quicker than we can follow it in terms of opportunities. And I think the major challenge, perhaps besides channeling it to the users, is making sense of it. I think the DIAs are designed to really also provide societal impetus to use and improve the uptake of Copernicus data. But I think in terms of scale, that's quite far for many of the questions you're dealing with, because a lot of the Sentinel data is not fine resolution enough for early detection of particular diseases. I think in the drone segment, when I go to conferences, it's mainly private sector actors who present packages that are often presented as a panacea, sometimes a bit questionable in the underlying science. But I think that's moving incredibly fast also, not only towards users, but only using data from end users.
Sorry, I can't see whether there are questions behind me, but I was just going to try to sort of ask a question of the panel, sort of putting myself in the shoes of an NPPO head with a particular problem, say an outbreak of something on oak trees that makes them go yellow, and you have 2 months in which to find the infected trees, and you have a budget of €50,000. What do we do? What's the advice? Can you do anything for 50,000 in 2 months? Do we just employ more inspectors, or is there a remote sensing component to the action in those circumstances?
I'd refer to my trade-off questions. Yeah. So if you came to me over coffee with that question, I'd ask you, how big is the area you want to monitor? How frequently you need to have an update? What is the scale of the feature you're looking for? And basically get an understanding of the disease system. Yeah. Based on that, you probably scope out what is realistic, what is not. When we looked at Xylella, we were along that spectrum as well. I mean, the initial visual symptoms are single branches. We didn't know if the entire tree is actually affected or not. So based on that, you kind of scope out what is feasible. If I look at the cost of what we did for Xylella, then 50,000 in our experience is not a no-go a priori. If it is it means you can do something for that amount of money if it is a relatively small area, for example, or it is something that is so widespread that you will pick it up over very large areas as well.
Just to add something on the discussion on citizen science, I know that there are already initiatives, for example, in space science. There are websites where galaxies are displayed, and citizens can classify this based on shape, and this helps a lot the scientists working on it. So I think that what we have to do as plant health is, as Peter said, make the images available in a way that users can use it and make the game funny for people to use it.
Thank you. The question, yes, the lady.
Hello, my name is Hubert Skoneczny. I'm from the from the Institute of Aviation in Poland, and I want to refer to the first question, how to fill this gap. And I think that involvement of the key stakeholders into the project is crucial from the very first day. Of course, there are different types of the projects, and this is not always possible. But in Poland, for example, we have this founding program where part of it requires the very specific consortium. It has to be a research organization and a private company. And the results of the projects, you can do 3 things with the results of the project. You can sell them on the market, you can sell license to use the results, or you can implement the results directly into the private company so they can use them right after the project finishes. Thank you.
Thank you. That's an interesting comment. And would you like to make a reply to that? Yeah.
I will say something about the first question, to transfer the knowledge to practice. I think it's not important to transfer this really because this is not working. This process or the scientist this information is also complicated. Remote sensing analysis are so complicated. I think I see 3 points what are important. The first one is that we have to create a multi-source network for plant protection. And this is really a network where the data, the resources, the knowledge, the tools are linked together or integrate together and working. It's working in the cloud. Then the farmers and the practicants have to get easy access to this network, to this data, but not directly to the data, more to this network, and to get really easy tools that they can ask questions, especially what is the soil moisture of my field, or what is the vegetation characteristics of my field, and so on. So that they really, this network can help to give them information, spatial information, it's from satellites, from airborne and spaceborne and whatever, but that they can really ask this question and to manage this for practice.
Thank you. And then I think there was, sorry, the lady there.
Sorry, I'm Chloe Barnes from 2XL Aviation. I just wanted to make a comment about finding all of the yellow oak trees and the idea of having more of a proactive approach and not reacting to individual pests, but perhaps learning from some of the science and putting in place measures such as tree species classifications that Paul was talking about that allow you to know where all the oak trees are, so that when a new pest arrives, we can learn from all the research that's happened and have a faster implementation. Just wanted to add that comment.
Yes, I think clearly a sort of a clever integration of all the different data sources, and that's what takes a lot of effort and a lot of time. We're running a little bit low on time, so there's a question over here. Yes.
Thank you very much. Talking about remote sensing, your view of this room is certainly not hyperspectral. So, but what I wanted to say is, your question at the beginning, end users, government agencies, researchers, and so on, all of us, or most of us here, from the government agencies, are also the end users. That we must make clear. We are not talking here about farmers. Farmers have, in our field, not much to do. We are the end users, and we use remote sensing, or we could use remote sensing, for two very specific applications. One, when we have a pest in our country, which we try to officially monitor and survey in order to contain it or to eradicate it. And that was the application which we have seen in the presentations on Xylella fastidiosa in Italy. That is a very specific application of remote sensing. The other specific remote application for remote sensing is if we make a surveillance for new pests which may have been introduced, which we don't know yet. And the question is, in how far can remote sensing help there? For something which we don't know, really, for something which may cause symptoms, which may not have been described very well. And what is the threshold of detection of such things? Because that is for us the important point. If we get something into the country which is dangerous, we need to find it as fast as possible when the threshold is very low. Because if the threshold is big, then remote sensing doesn't help very much, because then people will pick it up and bring it to us. So it must be done at a very, very low threshold. And in how far is remote sensing giving us a tool to do that on a regular basis? That is for us the important question as end users, as government agencies. Thank you.
Thank you. Very, very good point. Yes, excellent. Any further comment from the panel on that? Yeah.
Because that is a critical point. It is. When you have the problem, you have to face, you know, the name, the host, and everything. When you expect something that you don't know, which host, so that is no name, that is the problem. But anyway, something can be, I mean, we have risky points. I mean, we have to investigate in the possible risky points, which are entrance, so airport, highways. I mean, there are some areas that we have to select as a sentinel of a possible entrance as a high risk. in those areas, I mean, this is our particular idea, is to develop and to combine all possible approach for a general acquisition of a problem in the area, trying to select also areas which have a big biodiversity as plant species, etc. So something could be investigated from very generally approach, cannot be pest specific, unless you want to, for example, a country that is Xylella free, want to see, well, I want to be prepared before entrance, but it has a name. But if you want to generalize this, you have to generalize also the approach. It cannot be specific on a crop. So you have to have select areas which have also different host species. And on that, spots. Try to combine not only remote sensing, but many other approaches. This is a problem, of course. But remote sensing can help. Also in changing detection, every year you see that spot, is something is occurring, changing, and then you go and check. I mean, it's a light approach, but it's an approach.
I hope you were being deliberately a bit provocative. Because in essence, you're asking partly to do the job from A to B, A to C. So I'd like to argue there's contributions that can be made that you didn't include, which is host species mapping from remote sensing. I assume it can save a lot of time if as soon as you know what host species are, you have detailed maps of where they are. And you might not get your final answer for your survey from remote sensing, but I would think it can save make it a lot more efficient and save you time that way. I think, if I remember correctly, the report that's coming from the first project that will be presented later actually is structured along that cycle of early detection, once you have an outbreak monitoring, and once it's really there. Another aspect that might not be so prominent, but that might be overseen, is that of damage mapping. Actually, we have not shown them, but a lot of the satellite applications, not so much on perhaps the regulated pests, but are of natural pests, have focused on the big bar beetle outbreaks in the US, for example. And those you can see from satellite, because they affect entire landscapes. There could be a use of remote sensing when the focus is on the front end of an epidemic to actually help estimate the extent of the damage behind that front end. So I think there's those nuances as well to consider.
Thank you. Now I do have one eye on the clock. If there are any more sort of urgent questions or comments, we could take one more. And there's one hand going up.
I will be brief. I'm Pasquale Di Rubbo from the European Commission DG Sante, the Plant Health Unit. So just to have some views from the panel. We have learned this morning that there are quite a lot of investment behind these technologies, and also the need to share expertise and knowledge. And I was wondering to which extent which kind of model we can see in front of us in the next years for MPPOs, for official inspectors. Do we want investments be made by each office in charge of official inspection on the ground? Do we want to find synergies across regions, across member states? Do we want to find synergies across climatic regions sharing the same risk, or across same host plants present in the member state? I mean, which kind of strategy would you suggest for MPPOs interested in getting involved in this pathway, in this nice journey? Thanks.
That is quite, I think, a high-level sort of political question. If any of the panel would like to answer that immediately now, please do. But I suspect that might be more of a question actually for this afternoon. But would anybody like to respond immediately to that? I think that's a question I think needs some reflection over lunch. And if everybody could reflect on that a little bit, I think we will return to that question in the afternoon discussion session. Well, then, I think what I will do now, let's close this session for lunch. We've done with very well on time. We're bang on the schedule, really. Okay, a little bit over, but we have 1 hour for lunch, which should be long enough. What is the arrangements for lunch? Can we use the cafeteria, which is where down? Just outside. Okay. Then I would just ask everyone to have a nice lunch and come back promptly at 13:15, please. Thank you.